Lesson 6.5 and 6.6 on the circumference and diameter ratio. Now, I hope that the concept of circumference is a review from previous grades. Primarily, circumference is in reference to a circle and the length around the circle. Now, to calculate the circumference of a circle, I hope you've done these calculations before. The circumference can be calculated by taking the radius of a circle, that's the length from the center of a circle to its outside edge, multiplying that by 2, and then multiplying that by pi. Another way of calculating it, if you know the diameter, is to actually take the diameter and just multiply it by pi directly. Pi is the ratio between the length of a circle's diameter and the length of its circumference. So that's why we multiply the diameter by pi. Remember, please, that pi is 3.14159265358897, and so on and so forth. This is a very long, complex, irrational number that we sometimes approximate by just using 3.14. But this leads to a dilemma of sorts, because whenever we round, we're actually cutting off some of the value of the number itself. And mathematicians don't like to just remove value entirely from an answer. But to help give you a better understanding of what's going on here, let's start with a simple example problem. What's the circumference of a circle that has a radius of 5? I'm sure you've done these problems before where you take the radius of the circle, you multiply it by 2, and then you multiply that by 3.14, which is our approximation for pi. Do those calculations and you get 31.4 centimeters. But again, this is an approximation. This is not the exact answer. So there's another method of calculating the circumference, and that method is called in terms of pi. Instead of using an approximation for pi, whether it's 3.14 or 3.14159, instead we keep pi as pi. We don't touch it. We treat it almost as if it was a variable. And we only multiply the constant terms. 2 times 5 gets us 10, and then we just multiply 10 by pi. We get 10 pi, and we leave it like that. I know that answer may look incomplete, but it's an actual formal answer that is more respected, especially in higher level math, than an approximation of pi. Now, let's say, for example, we wanted to use a real-world problem that incorporates these calculations of circumference and radius and diameter. So, for example, let's say you try to fly around the Earth in a hot air balloon. If the diameter of the Earth is 8,000 miles, find the average speed in miles per hour that you would have to travel to circumnavigate the Earth about the equator in 80 days. Sounds complex at the start until you start to break the problem down into its pieces. First and foremost, what is the shape of the Earth around the equator? It's a circle. And we just spend a lot of time talking about how to find the length around a circle. So let's model this problem in terms of circles. So here's a circle that I've outlined in red around the Earth. Let's find the distance around the Earth. Simple circumference problem. We know the diameter is 8,000 miles. If we use an approximation for pi, 3.14, then we can actually approximate the entire circumference around the Earth by just taking 8,000 times 3.14. And we get approximately, well, using more precision, in this case 3.1416, we get a circumference approximately equal to 25,132.8 miles. So if we need to go around the Earth a total distance of 25,132.8 miles, and we need to do that in 80 days, then let's calculate the speed that we have to travel. So if we take 25,132.8 divided by 80, we'll get how many miles we have to travel in one day, 314.16 approximately. But we still need to calculate the speed in miles per hour. So there's 24 hours in a day. Divide 314.16 by 24, and we will get our necessary speed that we need to travel to get around the Earth about the equator in 80 days, which is 13.09 miles per hour. Thus concludes today's lesson.